The C part, we'll be talking about the diagrams, more of diagrams, the real depth, the apparent depth, and so on. So let's talk about a surface of separation. Let's say up it's air, and at the bottom it is water. Yep. So obviously this is a rarer medium and this is a denser medium, and this is the separation, the surface. Okay, let's say there is a stick. Okay, there is a stick which I have placed in water. Fine. How you draw a diagram is, first you draw a stick, you just make a reference like a normal, a perpendicular, a straight line vertically upwards, perpendicular to the surface. Yep. So out here, when we see from here, when our eyes, the observer standing out here obliquely to the surface, he feels the stick is raised. The bottom of the stick does not appear to be at the ground level. It appears to be slightly risen. That's what he feels. Somewhere out here, let's assume. So this is the place, this is the position where I observe the stick which is immersed in water. So this is nothing but a shift. It happens because of the refraction of light. So obviously what happens, what is the reason? Check. The rays of light come from here, they fall. Now I think personally, the rays of light are coming from a denser medium to a rarer medium. So if they come from a denser to a rarer medium, the bending is away from the normal. So somewhere like this. I feel that it's coming from here. This is the angle of refraction and this is the angle of incidence. And straight away it enters the eye of an observer. So what happens is, I know that the ray of light always propagates in a linear manner. Light travels in a straight line. So obviously I cannot assume or make it out that the light must have bent. The light must have bent by this much angle. Does not make sense. As a layman, we know that the light travels straight. So obviously I would have thought, okay, analyzed, experienced, observed that the light must have traveled straight only. So the light must have come straight from this point. So when I try to catch hold of a stick, in my hand there is just water. Stick doesn't come because stick is much below the line of my hold, my reach. So I can say, students, from the bottom, we call it as a real depth, the actual depth, RD. But I feel that the stick is out here. This is called the apparent depth. And this much portion has risen, and that is called a shift. So from here, we can make out on a formula. We can say that real depth is equals to apparent depth plus shift. I'll just write the shortcut here. Apparent depth plus shift. This is possible when the ray of light is falling, when it's falling from a denser to a rarer medium. So the ray of light falls from a denser medium to a rarer medium. Now that's important. If you go with another diagram from a rarer to denser medium, let's check that. Rarer to denser. Now this time the observer is in water. You take the same example and there is a bird flying in the sky. So I will take this as the surface of water. Come on. This is the surface of separation. We have same air up, rarer medium, and water at the bottom as a denser medium. Now let's talk about a bird. This is a bird flying in the sky. And there is an observer out here inside water. Fine. Let's start. The ray of light falls from a rarer to a denser medium. Can I say the bending is going to be towards the normal? Of course, the bending will be towards the normal. Fine. Something like this. Now what happens is, what happens is, actually, the observer feels that the light must travel straight. And if I trace it straight, of course, this line is a straight line. What happens is I feel that this is the bird. This is the position where the bird has stood. So if this is the observer, he feels the light is going straight. He feels the light is going straight. And here is the actual bird, which is not the scene. The actual bird is out here. So this is going to be the real depth. This is the point where the observer feels the bird appears to be. This is the apparent depth. And this much is nothing but the shift. So in both the cases, the shift is in the upward direction. That is for sure. In this case, I can say apparent depth is greater than the real depth, and apparent depth is equal to real depth plus shift. And out here, real depth is greater than the apparent depth. So there is only one change. In both of them, rarer to denser or denser to rarer, in both, the real depth and the apparent depth, they differ. But the shift is always in which direction? The upward direction. So if I now talk about my next answer in connection with this, what are the factors affecting shift? And all these things are phenomenon of refraction of light. So refraction happens when the ray of light enters from a rarer to denser or from a denser to rarer medium because of the bending, right? That's refraction for you all. Now, factors which affect the refraction of light. The first factor, talking about the factors affecting the shift, right? 3 factors affect the shift. The first factor, it depends upon the refractive index. Second, the thickness. Yeah, the thickness. And third, thickness of the medium, obviously. And third, it depends upon the color or the wavelength. That is the lambda. Now, tell me one thing. If I talk about the refractive index, more the refractive index, more is the thickness of the medium. And because of that, the bending will be more, the shift will be more. So it is directly proportional. More the refractive index, more is the shift. Second, thickness, obviously. Thicker the medium, more is the density, more are the atoms, more is the bending, more is the shift. So again, I'm just writing it is directly proportional. Color or wavelength. Lambda for red colored light is 8000 angstrom units. And the shift for the red light is the minimum. So I think it's inversely proportional. More the wavelength, minimum is the shift, minimum is the bending. And larger the wavelength. Violet colored light has a wavelength of 4000 angstrom units. The shift is maximum, right? So that was inversely proportional, directly proportional, directly proportional. Now, if you talk about certain formula, which I want you to by heart them, the proofs are not there for you all. So you can just remember the formula from the numericals point of view. The first formula, mu is equals to real depth upon apparent depth. Second, mu stands for the refractive index. So if I talk about the next formula, it is about the shift. Shift is equal to real depth bracket 1 minus 1 upon mu from air to a medium. That is when the ray of light travels from air to any medium. Now that medium can be anything. It can be a glass or a kerosene or oil or turpentine oil, or it can be water, diamond, anything. So mu air to a medium. And the third formula, you can say real depth is equal to apparent depth plus shift, or the other way around, apparent depth is equal to real depth plus shift. Now this all depends upon from where to where is it traveling, the light. According to this formula, it is the second one. And according to this formula, it is the first one. So it depends upon the travel of light, the propagation of light from one medium to another. So this is all in the C part. However, there are some consequences like twinkling of light, yep, like mirage and all those things. But those things, guys, I have already explained when I shot a live concept for you all. So just go through this and we'll encounter the last part of this chapter. The critical angle, the concept. Now, what is critical angle? In general layman's term, critical is a reference angle. Every substance, medium has a critical angle. Reference angle, look, for example, if I'm talking about water, the critical angle is 49 degrees. If I'm talking about a glass, the critical angle is 42 degrees. This is the reference. That means if the angle of incidence is greater than 42, the ray of light travels in some direction, which we're going to talk about. If it travels at an angle of 42, something else happens. And if the ray of light travels at an angle less than 42, there is some other observation. That means there are three different observations. So that is a reference which we take and we are going to check the diagrams, right? So if I happen to say a textual definition, critical angle is the angle in the denser medium for which a corresponding angle in the rarer medium is 90 degrees. Normal. I didn't understand anything here. Just check it now. Check. Case number 1. I'll talk about cases. Let's assume we'll take an example of a glass. Yeah, we're going to take an example of a glass. So, first rule, the ray of light should travel from a denser medium to a rarer medium. Now, that's your condition number 1. Ray of light should travel from a denser to a rarer medium. Now, the critical angle is 42. Mind you, let's make a ray of light incident at an angle which is less than critical angle, less than 42 degrees, a normal. And that's I for you all. I can say in case number 1, angle of incidence is less than 42 degrees, which is the critical angle. Okay. What happens is there is a partial refraction and a partial reflection. Majority of the light, okay, denser to rarer, away from the normal. Majority of the light, 96% approximately of the light is refracted. It enters into the other medium. However, some portion of the light is reflected also. So this is R1 stands for the angle of refraction. R stands for the angle, the angle of reflection. However, a very less proportion of light is reflected and majority is refracted, enters into the other medium. Alright, that's case number 1. Case number 2. Again, we have a denser medium from which the ray of light comes, enters into a rarer medium. Now, in the second case, angle of incidence is equals to the critical angle. They both are equal. So, I make a ray of light incident at 42 degrees out here. That is I is equal to C. What happens? The ray of light, it scrapes through the surface. That means it goes this way. It overlaps the surface and leaves the surface. And the angle of refraction, corresponding angle of refraction is 90 degrees. This is the condition for critical angle. And the third part, when the ray of light is incident at an angle greater than 42 degrees. So greater than 42. Again, please, yeah, it's coming from a denser medium going to a rarer medium. This is the angle of incidence. This is a condition of total internal reflection. Total, 100%. Internal, the ray of light remains inside, within the same medium. It does not go away, does not go outside. Nope. Reflection, how the name suggests, reflection. That's R for you. And I can say, come on, yeah, I is equals to R. Angle of incidence is equal to angle of reflection. Oh, come on. It is the laws of reflection, one of the law. And I can say, yep, for a total internal reflection, there are two conditions. Condition number one, that the ray of light should fall. The ray of light should fall from a denser medium to a rarer medium. That's first condition, yeah. And condition two, for total internal reflection to happen, the angle of incidence should be greater than the critical angle. So in this condition, I is greater than 42 degrees. All right. And if I talk about the second case, this one. This was the third case for you. If I talk about the second case, okay, please tell me, help me out. I is equals to C and R is equals to 90 degrees. So if I start about mu, that's my second answer for you all. Mu, I'm just connecting it. Ray of light is coming from a denser medium to a rarer medium. Okay. So let's talk about 1, 2, where 1 is a denser medium and 2 is a rarer medium. I have a formula. Mu, out here it is coming from denser to rarer. That is from glass to air. What should be the formula? It is sine of angle of incidence, that is sine C. Why the hell C? Because angle of incidence is equal to the critical angle upon sine R, and sine R is 90. Sine 90 is 1. So I can claim that mu, glass to air, is going to be sine C upon 1. Perfect. Reciprocate it. Mu glass to air is going to be 1 upon cosec C. Cross multiply. So cosec C is 1 upon mu GA, or you can write mu AG. That is cosec C. This is like a proof or a formula which you can remember. Alright, now what I'm going to do is, I'm going to club all the three of them and make it into a single diagram. And apart from that, we're going to check a few diagrammatic representations, how a ray of light enters and it refracts and bends it. Okay, so just go through this and we'll proceed with the last part of the chapter. Taking a 3-in-1 all together. Let's begin. Denser medium, rarer medium, fixed. A common point, a source of light. Okay, a source of light. So there is a torch. I'm just changing the angle of incidences at which the ray of light falls on the surface. Alright, the first one. Talking about this, where the angle of incidence, case 1, yeah, come on, case 1. Angle of incidence is less than the critical angle. Second case, where the angle of incidence is equal to the critical angle. Yep. And the third case, the angle of incidence is greater than the critical angle. Fine. What happens in the first case? In the first case, students, the ray of light enters into the other medium and just leaves off. From rarer to denser, bending, from denser to rarer, bending is away from the normal. Case 1. Second case, it goes perpendicular this way, scraping the surface. This is R. This is also R, 90 degree. And third, total internal reflection. 100% of reflection, no loss in the energy of light. Fine. After this, I'm talking about there are few diagrams which have been asked in the board exams frequently. The first of them, they ask you draw a diagram, okay, through a prism representing a 180 degree rotation, a 180 degree turning effect. It is this one for y'all. It's a pure geometry. Okay, pure geometry. You take a 45, 90 and a 45 prism and make a ray of light incident this way. I'll just take one ray for now and then we'll convert it into two of them. At 90, nothing happens. The ray goes normal to the surface. perpendicular. Wherever it strikes, the ray strikes an oblique surface, you make a normal. And start calculating. 45 plus 90 plus this angle, the outer angle, is going to be 180. So obviously this has to be 45. If this is 45, this is a normal 90. This is also 45. Now there is something called as a mean law concept. I'll just write it out here. Mean law. Now what does mean law stand for? What does it stand for? Check. M. M stands for more than the critical angle, the ray of light remains inside only. That means if the angle of incidence, this one, is greater than 42 degrees. Oh, come on, few minutes back, didn't I tell you all that for a glass, the critical angle is 42. So if the angle is more than 42, it will remain inside. The ray of light remains inside. Nothing happens. Total internal reflection. Angle of incidence is equal to angle of reflection. It goes somewhat like this. Fine. Now again, if this is 45, can I say the outer one is also going to be 45? Because this is like a 90 normal. 90 plus 45, this has to be 45. At an oblique surface, you make a normal. 45, complete thing is 90. Come on, this is 90. So this one is 45. I'm always interested in the angle between the incident ray and the normal. I am not keen on the angle outside. Nope. Again 45. More than 42, the ray will remain inside only. So the ray, again, total internal reflection, 45, 45, and this is going to be 90. So the ray goes down. So this is nothing but a 180 degree of rotation. Yes, bend. This is the diagram. You can also make one more ray just like a recuperation of this ray. Okay, the same way you made this one. 1, 2, and 3. All right, fine. And you just make normals. So 2 rays to be drawn. If I talk about another diagram with a 90 degree rotation, it looks like this. So you take a prism, again 90, 45, 45. Come on. This was a 180 rotation. The use of a 180 rotation is in binoculars. This is one of the applications I've written. Now when the ray of light enters, okay, it enters this way. First, it is entering at 90. Nothing happens. It goes straight. 45 plus 90, this has to be 45. I'm not interested in this angle. What you do is, you draw a normal. 45, 45. It's more than 42, it remains inside. Total internal reflection, 45 degrees, straight. 45, come on, yeah, this entire has to be 90, yeah, come on. And it goes straight. Another ray, you can draw, simply. Perfect, students, yep. So this is a 90 degree rotation. And the example, not the example, the application of this is in a periscope. Okay. Talking about another random diagram, a random figure. Yeah, you talk about as a 60 degrees, a 30 degrees, and a 90 degrees. Okay, just a random figure. How do you want the ray to enter? Let's make it enter this way. It's entering at 90. Now when it enters at 90, it goes without deviation. Come on, this is 90. 90, 60, by angle some property, this has to be 30. At this point, you make a normal. If this is 30, the exterior angle will be 60. Pakka, yeah, perfect. It's more than 42. 60 is more than 42. The ray remains inside. Angle of incidence is equal to the angle of reflection. Total internal reflection concept. It goes out here. Now, this is 60. This one will be 30, 90. This has to be 60. I am never, nope, not interested in this. First, you make a normal, please. This is the angle of my concern, which is 30. Oh God. Now, for the first time, it is less than 42. Can I say the ray goes outside? It leaves the medium. So now, 30 degrees is obviously less than 42 degrees. The ray will go outside. And since this ray of light travels from a denser to a rarer medium, bending is away from the normal. So this is the normal. It won't go straight. It will bend away from the normal. Somewhat random bend. Fine. And the last diagram I can take in a crash course is this one. Check the last one, guys. Okay. The ray of light falling at an angle of 42. Now, by observing this, students now they are in a haste. Fast. It's sir. This is critical angle. It will go through the surface, and I will laugh. Stupid. No, guys, no. Understand, please, yeah. Come on. This diagram which I drew, you never have to see this angle. I am tired telling y'all that first make a normal. You find out this one. This is 48. I am interested not in the outer angle. I am always bloody interested in the angle between the normal and the incident ray. Are you getting it or what? Come on, yeah. Now this is 48. Oh gosh. More than 42. Total internal reflection. 48. Fine. Let's calculate. If this is 48, guys, this is 42. Yep. Come on, this entire was 90. Don't screw my brains. 42. This is 90. By angle sum property, the outer one will be 48. Complete mathematics. And out here, when you make a normal, oh yes, finally 42. Now the angle of incidence has become 42. This ray will scrape through the surface. That because the angle has become equal to the critical angle. Perfect, guys. So this is the diagram. So I want you to go through this and hope for this chapter has been a successful attempt from my side to teach you.